Inverse functions. To convert a temperature given in Celsius to Fahrenheit temperature, we use the formula F equals 9/5 C plus 32. Conversely, to convert Fahrenheit into Celsius, we use C equals 5/9 F minus 32. These two functions are inverses. They go back and forth between each other. What I mean by that is, let's say we were to start with a Celsius temperature of 100. Well, F would then be 9/5 times 100 plus 32, which would turn out to be 212. If I then took this answer and plugged it into that function, I would get C equals 5/9 times 212 minus 32, and you work that all out, you get 100. And this is what we mean by inverse functions. If I take a value and I plug it into one function, I plug it into its inverse, I get back what I started with. And I could do it the other way too. I could start by plugging an F number into this function, work it out, take that answer, plug it into that function, and I'd be right back to where we started. So, the fancy math definition. We say F is an invertible function if there exists a function g such that FOG of x equals x. So when you do f and g, basically they cancel each other out, you get x back, and GOF equals x. And this is important that we can do it both ways, because we saw previously that quite often when we do FOG and we do GOF, we get different answers. If this happens, we say g of x is the inverse of f of x, and we use this symbol. Now be careful of this symbol because it looks a lot like an exponent, but it's not an exponent. This is, when we're dealing with functions, this is the symbol we use for function inverse. Alright, so first question. Are the following inverses? Well, to tell if they're inverses, what we would do is we would do FOG, and then we would do GOF. And if both of these answers turn out to be x, then the answer is yes, they're inverses. If one of those, or both of them, is not x, then the answer is no. Alright, so to do FOG, I start with g, I start with that, and I plug it in for that x right there. So I would have 2 times 1/2 x minus 3, or plus 3, yeah, minus 3, I mean, plus 3. Distribute the 2 through, that's x minus 6 plus 3, that's x minus 3. So right there I can stop and I can say no, they are not inverses. I don't even have to do GOF. I did FOG, I did not get just the answer x. They're not inverses. Alright, how about the next one? 2x plus 3, same function, slightly different one, 1/2 times x minus 3. Well, again, I do FOG. I have 2 times 1/2 times x minus 3 plus 3. This time the 2 and the 1/2, they multiply to be 1, so I have x minus 3 plus 3, that's x. At this point it would be very, very tempting to say yes, these are inverses, but we're not sure yet. The answer at this point is maybe. We now have to do GOF. We have to be able to do it both ways. So I start with f and I plug it in there. I'm going to have 1/2 times 2x plus 3 minus 3. Plus 3 minus 3, that adds up to 0. So I've got 1/2 times 2x. 1/2 times 2x is x. So the answer here is yes, those are inverses. And it makes sense because what this says to do is multiply by 2 and then add 3. Well, the opposite of multiply by 2 and add 3 would be subtract 3 and then multiply by 1/2. See, this one is close. This one seems like it should be the right answer because you multiply by 2 and add 3. This one says multiply by 1/2 and subtract 3. So they're not quite the opposites because here we did add 3 last. So the first thing we should do is subtract 3 to do the opposite. So that's why you need the parentheses. Alright, are these two inverses? Well, let's see. If I take FOG, I would take the square root of x, and then I would square it. And that does turn out to be x. If I do GOF, I would take x squared and then square root it. And it's very, very, very tempting to say that would be x. Turns out it isn't. And let me give you some examples here. I'm going to build a little table. It works fine as long as I plug in a positive number. If I plug in a positive number, 5 squared is 25, and then I do the square root of 25, I do get 5. The problem becomes if I plug in a negative number. If I plug in -3, I would have -3 squared and then do the square root. That's the square root of 9, that's 3. I don't get the original number back. In fact, you see what's happening. If I plug in a positive number, I get the same positive number back. If I plug in a negative number, I get the positive number back. That's a fancy way of saying that's absolute value. So this is a tricky one that almost always catches people. These two things look like inverses. They are inverses as long as you only use positive numbers. As soon as you start using negative numbers, you got a problem. So these two are not inverses for all numbers. All right. Next, let's notice something here. F of x is 4x plus 3, and f inverse of x, which is the same as g of x, is 1/4 x minus 3. You can do FOG and GOF and convince yourself that those are inverses, or you can just believe me when I tell you that they really are. I'm going to build a table. I'm going to take numbers, 0, 1, 2, 3, and plug them into f. Let's see, when I do that, I get 3, 7, plug in 2, that's going to be 8 plus 3, that's 11, and plug in 3, I get 12 plus 3, that's 15. All right, and then I'm going to plug some numbers into f inverse, or g, if you wish to call it that. The numbers I'm going to pick are 3, 7, 11, and 15. And it should be obvious where I got those from. But look what happens when I plug in 3. 3 minus 3 is 0. 0 times 1/4 is 0. Plug in 7. 7 minus 3 is 4. 4 divided by 4 is 1. And you're probably starting to see the pattern already. 11 minus 3 is 8. 8 divided by 4 is 2. And you can probably just guess that that one's going to be 3. So notice what happens. If the x values for f of x become the y values for g of x. And the y values for f of x become the x values for g of x. And that's what this next thing says. If f is an invertible function, the x values for f of x become the y values for g of x. And conversely, the y values for f of x become the x values for f inverse of x. All right, so this looks confusing and hard. Let's see, this says f of x is -2x plus 3. It wants you to find f inverse at 3. That means 3 is an x number for f inverse, or 3 is a y number for the original function. So what this is saying is, plug 3 in right there. And then figure out what the answer has to be. Well, I would subtract 7, -4 is -2x, which means the answer is 2. All right, so we have the same thing here. It wants g inverse at 1. That means 1 is an x number here, which means 1 would have to be the y number over here. So 1 would equal 4 times, sorry about that, 1/2 to the x. All right, well, this one I'm just going to solve by inspection, really. And what I'm thinking is if I plug 2 in right here, I get 4 times 1/2 squared, which is 4 times 1/4, which would give me 1. So again, we don't have the skills to solve that one as an equation, but we can solve it by inspection, or you could use your calculator. All right, the last thing for part one of this video is the reflection property. For an invertible function f, the graph of f inverse is the reflection across the line y equals x. What does that mean? Well, let's look at a graph. Here's my function. I'm going to graph f of x. To graph f of x, I would start at its y-intercept, which is 0, -2. Let's start making a chart down here. X, f of x, 0, -2. And then my slope is 1/3, which means I would go up 1 and over 3. 1, 2, 3. So this is the point 3, -1. And then I could do that again. I could go up 1 over 3. And I end up at 6, 0. I wish I'd have used a ruler, but I didn't. All right, so this is the graph of f of x. Now, to graph f inverse, I don't really need to know an equation for f inverse. What I know is it switches the x's and the y numbers. So if I have 0, -2 here, I'm going to have -2, 0 there. 3, -1 becomes -1, 3, and 6, 0 becomes 0, 6. All right, so I have -2, 0, -1, 3, and 0, 6. All right, so I'm going to try to make this one a little bit straighter. Use my calculator cover here. Ooh, it looks like that. I got off my cover. All right, so what we were saying is it's a reflection. So if I had done this better, and I drew the line y equals x would be this line. What should happen is, if I could cut my paper along this line and fold it over, this graph would fold over and become that graph. And that's what we mean by f inverse is a reflection over y equals x. Okay? You don't really need to know that so much as, if you draw the f of x graph, simply interchange the x's and the y's, and then you can draw the inverse graph. All right, that's the end of part one of this video. There will be a part two, so take a break and come back in a few minutes and watch part two.